This lecture is about reading data from a MySQL database. MySQL is one of the most widely used open source databases, and it's widely used partially because it's free, but also because it works really well. And it's again widely used in internet-based applications. Data are structured in databases, and then the databases, within each database, there's a series of tables, and then within the tables there are a series of fields. So you can think of each table sort of as a data set, and each field as, say, one of the columns of that data set. So each row in the database is called a record. If you want to know a little bit more about MySQL structure, you can look at the Wikipedia page, or there's quite extensive documentation at mysql.com. So here's an example structure that you would get for a particular database. So what you have is here, this is a database of employees. And so what you might have here are several different tables that are all linked together. So for example, you might have the departments that the employees are employed in, the employees themselves. You might have information about their salaries in a different table. And you might have information, say, about who their managers are in yet another table, and information about their titles in yet another table. So for each table, you get a slightly different kind of data type. And so one thing to note is that what this database schema shows is each of these tables you can think of as corresponding to, so one box corresponds to one data frame in R, so to speak. And all of the sort of listed variables here you can think of as the column names for that data frame in R. And so you'll notice that one of the sort of common IDs appears in all of these tables, they're sort of linked tables. So it's possible to go and sort of access, say, for an employee, which department they come from, and what their salary is, and what their title is. And so you can figure out also who their department manager is, and then the department managers are then organized into departments sort of in a structured format, so you can follow that back to find out who the employees are. So this is an example of a MySQL database, and so you have the data stored in all of these tables, and you want to be able to access them. So the first step in using the MySQL package is actually installing MySQL. And so this is a little bit complicated because it depends a lot on your operating system and the particular structure that you have. So if you go to this website that I've linked to down here at the bottom, you'll be able to install MySQL. And you can see that there's a version of MySQL for just about every kind of operating system that you might be interested in installing it on. And so there are pretty explicit instructions on how to install MySQL on all of those websites. We're actually going to be showing in this lecture an example of a web-facing MySQL server that we'll be able to access. But as an act of good citizenship to the world, I would appreciate if you didn't all go and try to access that one server, because we'll probably overwhelm them with the large number of people in the class. So a better example is to try to create a MySQL database on your own system and then play around with it. So the first thing that you need to do is install R MySQL within R. So on a Mac, you can just do install.packages R MySQL. For Windows, it's actually a little bit more complicated because of the way that the database drivers need to be set up and so forth. So you can actually see the official instructions here on this website. And then this guide I found to be actually quite a bit more sort of intuitive and useful. So if you are having a little bit of trouble getting it installed on Windows, that might be a good place to go. If you have more trouble, please go to the forums and ask questions. So we're going to be using a web-facing version of a MySQL database so that we can just show how the R MySQL package works without having to install MySQL and go through the process of actually building that database. The important point to keep in mind here is that as a data scientist, one role that you will have is likely to collect data from a database, and maybe later you're going to put some data back in it. But usually the basic data collection is already being performed before you get there. So you'll usually be handed a database and have to try to get some data out of it. So this is information about the human genome that's collected by the University of California, Santa Cruz. It's one of the most famous databases for genomics. And so they have a public-facing MySQL page, MySQL server. And so it gives you information here on how to connect. If you have MySQL installed on your computer, how to connect to their MySQL server. And so we're going to use that information and actually just connect within R. And what we're going to try to do is access a database and collect some information about a particular genome that we're interested in. So the first thing that we need to do is, once you've loaded the R MySQL package in R, you're going to use the dbconnect command to connect to a database. And so in this case, it's a MySQL database. You can actually use this DB Connect to actually connect to other kinds of databases as well. And so you saw from the page on the previous slide that the user that we're going to pass it is genome. And then you're going to pass it the host, which is just where the MySQL server is. And in this case, it's this web address here. So what this does is it opens a connection, and that connection is given this handle, UCSCDB. So you should always assign the handle, each connection a handle. And then what you can do is you can actually apply a query to that database. So what you can do is you can use the db get query command. So what that does is it'll go to the connection. In this case, the connection is to this database, and it'll run this MySQL command. So this actually isn't an R command. It's actually a MySQL command that we're sending to this database through the db get query function. And so then at the end, after I run that command, I'm going to use db disconnect. So I'm going to disconnect from the MySQL server. It's very important that whenever you're done analyzing data or collecting data from a MySQL server, that you disconnect from that server. And you should get a true response. That true is coming from the db disconnect because it's saying that we did, in fact, disconnect from the server. Then if I go and I look at result, what result will show is a list of all the databases that are available for that, all the databases that are available within the MySQL server that is located at this particular host address right here. So we're going to actually focus on one in particular, and that's HG19. HG19 is a particular build of the human genome, so it's the 19th build of the human genome. And so what we can do now is just run that db connect command again, but instead of just passing it the user, we'll also pass it the database. We'll say we want to access this database within this MySQL server. And then what we might want to do is see what are the tables within that database. So remember, on a server, there might be multiple databases, and within the database, there'll be multiple tables, each table corresponding to what you might think of as a data frame. So what we can do is look at all the tables that exist in the HG19 database. And so if you look at the length of that, in this case, it's very long. There are over 10,000 tables that are in that single database. So this is one nice thing about MySQL. It can store a large amount of data that we can get easy access to. So if you look at the first, say, 5 tables, you get these tables here. These are all different tables corresponding to various different elements that describe components of the human genome. Each table corresponds to a different kind of data set. So you can kind of think about it in the same way that the tidy data principles, you thought about each data set corresponds to its own file. It's the same way here. You get each different data type gets its own table. So one thing that we can do is, so suppose we know one table that we're interested in. So this is for a particular kind of microarray, which is a measurement technology used to measure something about the genome. So you can actually say, okay, I want to look in this database. This is the connection that we made to the HG19 database within the MySQL server. And I want to know what are all the fields in this particular table. So remember, a table corresponds to something like a data frame, and the fields correspond to something like the column names of that data frame. And so you can see if we look at the fields here, there are things like bin, matches, mismatches, and so forth. So what we can do now is, suppose we want to find out, say, how many different rows there are in this data set. So we already know something about the columns, right? Because this db list fields told us all the column names, and so there's something like 22 columns in this data set, or in this table. Then what we might want to know is how many rows it has. And so what we're going to do is send another query to the database. So it's db get query again. So again, we're going to pass it in quotes a MySQL command. This is a very special MySQL command that says select count star from this particular table. So what it's doing is it's basically going to count all of the records in the table, and it's going to return the number of records. So if you wanted to look at the number of records in a different table, you would just send this exact same command with the database you were interested in here and the table you were interested in here, and you would get the count of the number of elements in that table. So then the next thing that you can do is, suppose you want to get one of the tables out, you can basically get the data frame out from the data set. And so what you do is you're using db read table. So we pass it the database that we're interested in getting the table from, and then the table name that we're interested in getting the data from. And so what that'll return is then the data frame itself. And so if you look at the top part of that file, you can see this is the data that's actually been extracted now from that MySQL server, from that particular database and that particular table. So you can extract the data one table at a time. One important thing to keep in mind is that often in these MySQL databases, there'll be a huge amount of data stored. And so any particular table might be gigantic and might be too big to read into R. So one thing that you might want to do is select only a subset of the data. So you can do that with the db send query command. So what you do is you say db send query, and you give it the database again. And then we're going to send it a different MySQL command. And so the MySQL command here is select star, so it's going to select all the different observations from this table, the AFI U133 plus 2 table, where the mismatches variable, so you remember that's one of the columns in that data set, is between 1 and 3. So what we do is we send this query to the database, and so now that's stored remotely at the database, and then if we want to fetch the result of that, we use the fetch command like this, and that'll return this AFI miss, which will give us some information about only the samples that we've selected using this database query. So if we look, say, at the quantiles of the mismatches, so remember we selected the mismatches between 1 and 3, and you can see that the quantiles reflect that we only have data for which the mismatches are between 1 and 3. So the other thing that you can do is you can actually just fetch. So remember, when you use the send query command, it sent it to the database, but it didn't try to suck the data back to your personal computer yet. If you only want to suck out a very small amount of data, so suppose you just want to see a little bit of the data and make sure that you don't accidentally suck down a gigantic table, you can use the fetch command and you can tell it only bring back the top 10 records. And so what you've got now is just a very small data set that only contains the first 10 rows of that table. When you do that, you need to clear the query. So you remember you sent a query out to the MySQL server, and now it's still sitting out there, and you fetched the data back, but it didn't stop that query from still being out there at the MySQL server. So you need to do db clear result to clear that query from the remote server, and it should return true again because you've cleared that result. So if you look at this small data set where we fetched only the top 10 rows or observations, you can see that that produces a data frame that actually has a dimension of 10 rows as well. So what we've done is selected a very specific subset. An important point here is that you can basically send any MySQL query that you would like up here within the quotes. So it's a little bit beyond the scope of this class to teach you all of the different queries. The most important ones are the queries that I've shown you about selecting the sort of the total count and selecting all of the observations that are subject to some particular conditions. But if you go to the MySQL documentation, you can actually come up with a query that will allow you to very flexibly select almost any sort of subset of rows or columns from a data set that you're actually interested in selecting. Remember to close the connection. So this is one of the most common mistakes when using accessing a database from R, is that you open a connection, you select some data out, and then you go happily on your way. You should try to close the connection as soon as you don't need the connection anymore. So immediately after extracting out the data that you're interested in, you should close the connection and move on with the rest of your script. The R MySQL vignette is very good. It gives you access to a bunch of other MySQL commands that might be useful for selecting data for your particular examples. There's also this very nice collection of MySQL commands here, very nicely organized, that will give you a lot more information if you want to be able to use them. One thing to keep in mind is that I have shown an example here of a public-facing MySQL server, and so what I've done primarily for this analysis is select data from that server. Please do not access that server to delete, add, or join things. In other words, don't push anything back into the server, only suck things or select things out of the server. So you should only be using the select command. Another important component is that we, again, are a large class, and so if you all hit that server at the same time, it will likely cause problems for them. It's much better to practice on your own local version of MySQL. In general, you need to be a little bit careful with MySQL commands because you can delete data that other people are working on. So a nice blog summarizing some other commands that are used with MySQL and R is right here. And so if you want to take a look and learn a lot more, there's a ton more that can be learned there. And R and MySQL play very nicely together if you want to get data out.